Bismillahirrahmanirrahim. In the previous slide, we started definition and types of differential equation. We continue that portion in this second video, and the full list. The full list of non-linear differential equations is one. I gave in the previous slide that if there is a power of the dependent variable is nonlinear, and number two, if there is a product of the dependent and independent variable is again nonlinearity. Number three, if we have a transcendental function of the dependent variable y, this is also nonlinearity. And number four, I left in the previous slide. If I have non-linear power of the derivative, let's say it is square, and that is equal to y. So the power of the derivative other than 1 is also a nonlinearity, and these applies these concept of nonlinearity applies for higher orders. Ds and PDs. Okay, so basically these are four types of nonlinearity occur in ODs and PDs. The first is power other than one of the dependent variable. The second is the product of the dependent variable and the derivative. The third is a transcendental when it contains a transcendental function of the dependent variable, and the third one is non-removable non-linear order degree of the derivative. So this is second degree first order ordinary differential equation. So these are four types, and you can easily check that whether the given differential equation is linear or non-linear, keeping in mind these concepts. Okay, now there are two types of these. Homogeneous. So what is homogeneous? Homo mean if let's say I'm taking nonlinear and equal to 0, this is homogeneous. And non-homogeneous if I take let's say the same equation equal to some function of x, let's say x, this is non-homogeneous. So what will be a simple check for the homogeneous and non-homogeneity? For homogeneous, you see this differential equation y is equal to 0 is a solution. and you see y equal to 0 is not a solution. So that is a simple check whether the given differential equation is homogeneous or non-homogeneous. If y equal to 0 is solution, then that will be a homogeneous differential equation. And if y equal to 0 is not a solution, then that will be non-homogeneous differential equation. Okay. So that is the homogeneity and non-homogeneity concept in the differential equation, and it applies also to the PDEs. Let me take uxx plus ut equal to 0. This is homogeneous because u equal to 0 is solution. And if I take some function or constant, or let's say it is t, this it become non-homogeneous, is not homogeneous, is now non-homo. So that is also applied to the, because it's non-homo, because u equal to 0 is not a solution. That is the homogeneity and non-homogeneity of the ODEs. Also, there are another concept of autonomous. So what is autonomous? Autonomous. Autonomous. Autonomous ODE. Maybe there will be something wrong with the spelling, but autonomous ODE is the one which is explicitly independent of, let's say, the independent variable. Let me write one, y dash, let's say y double dash plus 2y dash plus y is equal to 0. So is autonomous if x not appear explicitly. So that is autonomous differential equation. You see, it is also homogeneous. But if I write this differential equation to be y double dash plus 2y dash plus y is equal to a constant. Now you see, is non-homogeneous, but it is autonomous. This is an autonomous equation because there is no x. So the non-homogeneity, the homogeneity violate, it become non-homogeneous, but again it is autonomous differential equation because there is no independent variable appear explicitly in this differential equation. So some differential equation are autonomous but non-homogeneous. If I take the same differential equation, y double dash plus 2y dash plus y equal to, let's say, x, then this is non-homogeneous, non-homo, non-auto. So this is non-homogeneous and non-autonomous differential equation, and that is We will continue if we left with the types and the types in concept of the DEs in the next slide, in the next video, or we will start with the first order ODEs. Thank you.